All right, let's take a look at pages 19 and 20. So multiplying fractions, whole numbers, and mixed numbers. When working with fractions, whole numbers, and mixed numbers, what we want to do is convert the whole numbers and mixed numbers to improper fractions first. Improper is the way that we want to work with these fractions, improper fractions. So then we're going to follow the same steps that we followed before. So basically we're combining two skills. We're combining turning things into mixed numbers and multiplying fractions. We can look at this as some rules. So if you have A times B over C, that's basically A over 1 times B over C, AB over C. We don't even really need to write that one. If we have A and B over C, so there's our improper fraction, times D over E. Well, A and B over C, remember, we know how to convert that to an improper fraction. That's A times C plus B over C times D over E. You end up getting A, C plus B times D over CE. Looks a little complicated, but again, it's just a matter of doing one thing that we've already done, turning it improper, and one thing that we've already done, multiplying fractions. Let's take a look. If we have some examples, let's start with example 1, 12 times 3/8. 12 times 3/8. Now that's a whole number times an improper fraction, so I want to turn that whole number into an improper fraction itself. Excuse me, that's a whole number times a fraction that happens to be proper. Could be either way. But to turn this into an improper fraction, we put it over 1. We have 12 over 1 times 3 over 8. And we can either multiply straight across, getting us 36 over 8, or, let's do this in green, we can divide top and bottom by 4. I get 2 down here, I get 3 up here, and then I get 3 times 3 equals 9 halves. Now, why didn't I get that here? I have 2 different looking answers. Well, remember, we were comparing fractions just a minute ago. 36 over 8 and 9 over 2 are the same because we can divide top and bottom by their shared common factor of 4. So our final answer, however we do it, is 9 halves, or we can turn it back into a mixed number. 2 goes into 9 4 times with 1 left over. So I like to see both answers unless it specifically asks for just one or just the other. Okay, so let's look at example 2. I'll give this one for you to do. 12 over 18 times 24. There are a few ways to do this. I would recommend simplifying first. Take a look at that 12 and that 18. They share some common factors. How can you make these numbers smaller so that they're easier to deal with? Example 3. We have 3 2/3 times 6 sevenths. So you are converting to improper, multiplying straight across. Maybe we can simplify early, maybe we simplify later, maybe we can't simplify at all. I'll do another example with you. Let's do one where it's 2 mixed numbers times each other. 2 5/8 times 4 2/7. Okay, I'm just going to make them improper. 2 5/8, that's 2 times 8 plus 5 over 8 times 4 2/7, that's 4 times 7 plus 2 over 7. Working through, we get 21 over 8. Order of operations says multiply, then add. We'll talk more about that later. So 21/8 times 30 over 7. And I like to simplify early when I can. I say, wait a second, this is divisible by 2. This is divisible by 7, top and bottom. And I'm left with 3 times 15 over 4. That's simplified improper. If we want it as a mixed number, 4 goes into 45 11 times with 1 left over. So we have 11 1/4 as our final answer. This makes sense. This is roughly 2.5 times a little more than 4. So 2.5 times 4 is 10. This should be a little more than 10, and it is. So just kind of ballpark in the right area. If I had gotten 111, I would know something's off because I'm taking 2.5-ish times 4-ish. You can always think about those in terms of what they actually represent. Number 5, example 5. Oops. Go back to blue. We have 2 1/5 times 8 1/3. And example 6, 7 1/2 times 2/3. Again, I want these as improper fractions and mixed numbers when you can. This last one's going to work out just a little bit differently. See what you can do with it. And let's take a look at page 20. So we have some application problems on page 20. We're making a pie crust. Notice that this gives us 4 pie crusts. We want 2 pie crusts. Think about how we can figure out how many of each ingredient we want. What kind of operation are we doing? What kind of numbers are we using? How are we doing this? Number 2, we've got a vacation, and we're trying to figure out how much we have to set aside ahead of time. And number 3, we've got a pie chart, and I'll do the first one for you. We've got a 24-hour day, and I see that sleeping takes up 1/3 of my day. So I have 1/3 of 24, or equivalently, I could do 24 times 1/3. Either way, I put my 24 over 1. I can simplify early and divide top and bottom by 3. 3, I get 1 and an 8. And I get 8 over 1, which is 8. I can simplify later on. I get 24/3. Now I divide top and bottom by 3, the largest number that goes into both. I get 8 over 1 equals 8. And in both cases, the answer is not just 8. It's 8 hours. I want to have my units. I want to make sure that this makes sense. If I had gotten 80 hours, wait a second, I'm not sleeping 80 hours in a day. So again, having the unit helps you remember that this is a number that represents something. I'll give you a chance to work on that and meet you in the next video.